Okay, now we are going to discuss this exercise. This is 2.2.5 and the question number 8 is you have to factorize, but you have to take the help of this identity a plus b whole cube is a cube plus b cube plus 3a square b plus 3ab square. See, sometimes you may ask her how you are coming to know which identity are to be used. So you have to get familiar with the identities, like in which identity you have got four terms, and what you can see this cube is there in first term. So by familiarizing yourself with the identities, you can easily decide which identity are to be used or which identities will be used. So that is the decision that you have to take, but that call can be taken only when you are familiarized with all the identities very well. So you see this, I can see this 8a cube, this is b cube. So I have to find out, this is the RHS that is with us. You can see this RHS is with us. We have to convert that into LHS. And to convert that into LHS, you need to know what is A and what is B. So I can see here this 8a cube, this can be written as 2a whole cube. And this is your b cube. So this b can be written as b whole cube. Now in these two terms, you have got the value of a. This is your a and this is your b. So now rest of the term you will write yourself. So this next one is 3a square means 2a whole square, and this is b means b here, and then 3a means 2a and b means this is b whole square. So if you open these terms, you will get this and this term, but your work is not there now to simplify again, because you'll get this again. So simply you write this is 2a plus b whole cube, and that can be written thrice: 2a plus b, 2a plus b, 2a plus b. Even if you don't write this three times, it's okay. You can write this 2a plus b whole cube. So this is the answer of your first part. Now come to this. This is the important question. Now you know the identity of a minus b whole cube also, that a minus b whole cube is a cube minus b cube minus 3a square b plus 3ab square. So if you know the identity, you can apply this here. You see, at place of a you can see 3, this is p whole cube, and at place of b this is 1 by 6 whole cube. After getting a, this is the first one is your a, this is your a, this is your b. So after getting this a and b, you need to just expand it in this form. So next will be this 3a square means 3p, and this is b means 1 by 6 plus 3 means this is 3p, and this is 1 by 6 square. So if you simplify them, you will get these terms, but no need to simplify them again. Now you can write this as 3p minus 1 by 6 whole cube. So that can be written as thrice, as I told you earlier also, or you can write it that way also. You can just write 3p minus 1 by 6 whole cube. So that's okay. So this is the answer that you have done the factorization of this part. See this now question number 9, and this question number 9, there are two parts, first part and second part, and these two parts you treat them as a formula. You keep using these formulas till your till the time you study mathematics. So rather than here we are verifying, that's okay, but treat them as the identity. So identity, you see, you will take your RHS when you have to verify. I'm just clarifying the meaning of verify. When somebody is asked you to verify some statement, it means you have to show that LHS is equal to RHS. What some students does, they write x cube plus y cube and equal to, they start solving like this. If you are already assuming that both are these equal, then there is nothing to verify. So you have to take both the sides separately, and you have to show that RHS is equal to LHS, or you can say LHS equal to RHS. So never do this mistake. Do not take both the sides side by side. So this RHS, you can apply the distributive law. This is x bracket. You can take this complete bracket xy. This is y square, and then plus y. This is x square minus xy plus y square. Now open this becomes x cube, this will become x square y, this will become xy square, this will become y x square, this will become xy square, and this will become y cube. So you can see all terms are now getting cancelled. Some only two terms will be left, x cube and y cube. How you see? This is x square y, this is x y x square. So same terms with negative sign and plus sign, negative and positive sign will get cancelled. Similarly, these two terms will also get cancelled. So you are left with only x cube plus y cube, and this is equal to LHS. So you have proved that LHS is equal to RHS. That is the correct meaning of verifying. Now your second part, just I am writing the second part and you will be proving it yourself, and that part is x cube minus y cube is equal to, this is x minus y, and this is x square, this is plus xy, and this is y square. So this way, the same way that I have followed, you can also prove that second part, and that also you treat as your identity. That will be used again, on a major scale in higher classes. Come to now this question. Factorize, this is 27y cube plus 125 z cube. And now you see this. That identity is looking similar to this, the first part, in which x cube plus y cube is equal to x plus y, x square minus xy plus y square. So you need to just find out what is your x here. So this is 3y, you can write this as whole cube, and this 125 can be written as 5z whole cube. Once you have found your x and y, you can use this identity as it is. So this is your x plus y means 3y plus 5z, and x square means 3y whole square minus xy means 3y 5z, and plus y square means 5z square. So after simplifying, you will get the factorization, you will get the factors. So this is 9y square, this is 15 yz, and this will become 25z square. So do not try to factorize this further. This is fine. These two factors you have got. This is your question number 11. Factorize 27x cube y cube plus z cube minus 9xy z. So before I start the factorization, I would like to give you the identity based on this. So identity is a cube plus b cube plus c cube minus 3abc is equal to a plus b plus c bracket a square plus b square plus c square minus ab minus bc minus ca. This is the identity of a cube, b cube, c cube. So you can see that the identity is a cube plus b cube plus c cube is minus 3abc is equal to a plus b plus c bracket a square plus b square c square minus ab minus bc minus ca. So just you need to identify what is a and what is b, and then you can factorize it very easily. So I can see this 27x cube can be written as 3x whole cube, and y is y whole cube, and z is z whole cube, and ultimately you write after getting abc 3a means 3x into y into z. So you have got this side. Now apply this identity. So according to this identity, this is a plus b plus c. So 3x plus y plus z, and bracket this 3x square y square z square minus ab 3x into y minus bc means yz minus ca means z into 3x. So you simplify this 3x plus y plus z, and this bracket will become 9x square, this is y square, this is z square, this is 3xy, this is yz, and this is 3zx. So this is what you have found, and that is the factorized form. So do not try to factorize this further, because this is fine. You can show this way only because I have used this identity. Now this question number 12. This question number 12 is very important, because you have to now verify that. But we are going to use this same identity as we have used in question number this 11, which is written in blue color. So you can see this x cube y cube z cube minus 3xyz. It can be written as a plus b plus c, a square b square c square minus ab minus bc minus ca. Now further we see what can be done. So now you have choices. You can go with two ways. First way, that you take LHS and show LHS equal to RHS, or you can use your RHS and you can show this is equal to LHS. So choice is yours how you take it. So now what I have decided, that I'll go with my LHS. So I'll take LHS. So my LHS is a x cube plus y cube plus z cube minus 3xyz. Now according to this identity, it can be written as x plus y plus z bracket a square means x square plus y square plus z square minus xy yz and minus zx. But you can see this is not looking like this. Something has to be done. So what I'm going to do, I'm going to multiply this second bracket by 2 and going to multiply also and divide by 2 also. X plus y plus z. So if I'm multiplying by some number, I have to divide also, so that it will get cancelled and it will remain the same. So this is x square, this is y square, this is z square minus xy minus yz minus zx. Now this 2 I'll get inside. So this x plus y plus z. Now and this 2 will, I'm just writing this here because this is all in multiplication, so it never matters, and this 2 is going to be multiplied by all of these terms. So it becomes 2x square plus 2y square plus 2z square minus 2xy minus 2yz minus 2zx. So after this step, you can write 1 by 2. This is x plus y plus z. Now this x square, this is twice of x square. So it can be written x square plus x square. So I am going to do this x square, and I'm going to take this y also at once. This is y square, and I'm taking this 2xy. So this is minus 2xy, and next I'm going to take this y square. You see y square, 1 y square is taken here, 1 y square is taken here, so 2y is complete. Then z square, you can take 1 z square and take 2yz, this one. Next your 1x square is left and your 1z square is left, so make the group of that x square plus z square and take this minus 2zx. And why I'm doing all these, this should be clear to you from what you have to get in RHS, because this is x minus y whole square. X minus y whole square can be obtained after getting this, y minus z whole square can be obtained after getting this, and z minus x whole square can be obtained after getting this. So last step will be just to apply this identity x plus y plus z, and the first three terms will give you x minus y whole square, and these three terms will give you y minus z whole square, and this will give you z minus x whole square, and that is your RHS. So this is hence verified. So this way you can verify these types of questions. So in this proof, only one thing is important about this step, like why you are multiplying and divide. Some of you might ask, but you see in the answer I need 1 by 2. So to get 1 by 2, I have taken 1 by 2 from my side, but if I'm taking from my side, I have to adjust that also, because the original one should remain the same. So I have divide by 2 and multiply by 2. So this is what the key point of this part, and this is important part of the exercise. Now read this question. In 15, you have to find length and breadth, and this area is given. You know that area is of rectangle, the area is L into B. So area is always equal to product of two factors. So now we are going to convert that area into factors, two factors. So one factor can be called length and second factor can be called breadth. So now you see that area, I'm going to write this 25 a square. This you can see which formula, if you can factorize, this is really good. 25 a square, this is minus 35 a plus 12. So you have this splitting method, so you can split, you have done this splitting method, so I'm doing it for you again. So this a into c we do, this is 25 and this is 12. So a is 25 and c is 12, so 25 into 12. So rather than you multiply this again and again you find the factors, better you see 25 factors are 5 and 5 and 12 factors are 2, 2 and 3, and last one will be 1. So you can do this yourself, how you do. And you see for two numbers, the first number I'm going to take in one group is 2, 2 and 5, and second group is I'm going to take this 2 is done and 5 into 3. So I have got two factors as this 20 and this is 15. So sign, you decide that you want plus, a into c is plus, so and your b is negative, your b is minus 35. So you can take this minus 20 and this minus 50, because if you add them you will get minus 35. If you add them you are going to get minus 35, and if you multiply them you are going to get 25 into 12, that is 300. So this is 300. So now this is completely your choice how you decide the factor, but you have to keep in mind two things, that your product should be equal to a into c and your sum should be equal to b, which is minus 35. So now I'm factorizing this. This is 25 a square and this can be written as minus 20 a, and this can be written as 15 a, this is 12. So 25, we can see that 5a is common, so this is 5a and this will be 4, and from here you can get 3 common, so this is 5a minus 4. So now I have got 5a minus 3 and 5a minus 4. So any one of the factor can be called length, and any other factor, the second factor will be called breadth. So L equal to 5a minus 3, this is some unit I am mentioning, and b, which is breadth, I can say this is 5a minus 4, this is again a unit. So this way you can write your answers. Keep in mind your area is length into breadth, and that is area is the product of two factors. Now come to this question number 16. Find all possible dimensions of the cuboids whose volumes are given below. The first one is 3x square minus 12x. So here in the beginning I would like to say that volume is your length into breadth into h. Now what does it mean? It means that volume is the product of three dimensions, or you can say the volume can be expressed as the three factors. One factor is L, second factor is B, and third factor is H. So in our questions we are going to convert the volume in as a product of three factors. So this, you see, this 3x square minus 12x, so you can take 3x common, and from here it will be x and it will be minus 4. So you can see you have got three factors. The first factor you can say this 3, second factor you can say this is x, and third factor is x minus 4. So I can write this L as 3 unit, B is x unit, and x this is h, which is x minus 4 unit. So this way you can find length, breadth and height, and so you can interchange all these. This is not compulsory that you always take first one as length, this is as breadth, this is as height. This can be height, this can be breadth, this can be length, or this can be length, this can be height, this can be breadth, because ultimately the product will remain the same. Volume will always be 3x square minus 12x. Whatever you assume, this is L, B, H, or you can take B, H, L, whatever way you want to take it. Now this second part, you see, the second part is volume is given. This is 12k y square 8k y minus 20k. So from this volume you can see 4k can be taken out common. So from here 4k, this will be 3y square, and this will be then 2y, and this will be 4k have taken, so this is 5. So your 4k has come. Now you can simply you can split the middle term. This is 3 5 is 15 and 3y square, so you can write this as 5y minus 3y minus, you can write this as 5. So this is 4k. 3y, you can take this y can be taken common, so y you take, then 3y plus 5. Here minus 1 you can take common, 3y minus 5. So this will become 4k, and this will be y minus 1, and this is 3y plus 5. So now you have got three factors again. First factor is 4k, second factor is y minus 1, and third factor is 3y plus 5. So this time I am assuming little differently. L I am taking as y minus 1 unit, and b I am taking as 3y plus 5 unit, and h I am going to take as 4k unit. So this way you can solve all these questions. Thank you. If you like the video, please share and subscribe. This is question number 13. You have to show that x cube plus y cube plus z cube equal to 3xyz if x plus y plus z equal to 0. This is very important result, and it's going to be used in a larger scale. So see this, how this proof, and you take this proof as a identity also, one kind of identity. So it's we know the identity that x cube plus y cube plus z cube minus 3xyz is equal to x plus y plus z. This is x square plus y square z square minus xy minus yz minus zx. So this is the identity that we know. Let x plus y plus z equal to 0 in this identity, then this will become x cube y cube z cube minus 3xyz is equal to 0 into this x square plus y square plus z square minus xy minus yz minus zx. So this side is going to be 0 because 0 into any number is 0. So ultimately your result is coming that x cube y cube z cube minus 3xyz is equal to 0. So you can lastly you can say this x cube plus y cube plus z cube equal to 3xyz. So this is very important result, and this result is there when you have x plus y plus z equal to 0. We'll see some use of this result in next question. See this problem, question number 14, first part, that minus 12 cube plus 7 cube plus 5 cube. You have to calculate it without actually calculating the cubes. So you see we take let a equal to minus 12, b equal to 7, and c equal to 5. Or you may say x, this as x, this as y, this as z also. So now your a plus b plus c, we do the sum. So this is minus 12 plus 7 plus 5. So this is going to be 0. Now you know that if a plus b plus c equal to 0, then a cube plus b cube plus c cube will be equal to 3abc. This is the result that we have just learnt. Now you replace that a as minus 12 cube, b you replace that as 7 cube, c you replace as 5 cube. Then this answer is going to be 3 into minus 12 into 7 into 5, which is going to be minus 12 6 0. So this is the answer that you have calculated without actually calculating the cubes. Now see this second part, this let x equal to 28, y equal to minus 15, and z equal to minus 13. So we do x plus y plus z. So this is coming 28 minus 15 minus 13, and the sum is 0. So it means your x cube plus y cube plus z cube will be equal to 3xyz. So you can write that 28 cube plus minus 15 cube minus 13 cube will be equal to 3 into 28 into minus 15 into minus 13. So that your answer is going to be 16, this minus minus plus 380. So this way you can use this result that we did in question number 3, and this is very important result.